So welcome to this video. In this video, we are going to discuss about book value and market value WACC. So this question has appeared in December 2014. So we'll start from the requirement. The requirement is calculate the market value weighted average cost of capital and the book value weighted average cost of capital of TCO and comment briefly on any difference between the two values. So we have to find out the book value WACC and the market value WACC. The most easiest to find is the book value. So we'll start from the book value, because once we found the book value, it's much easier to find out other values. So we'll start. It's going to be requirement A, and we are going to find out the book value of WACC. So for solving this, we have to create a table. Source of capital, the source of capital, and then we'll have the amount of that capital, a working note. Then we'll get the proportion of capital. So then we'll get the cost of the capital and have another working note. And finally, we can multiply the proportion into the cost, and that will give us our answer. So not all tables are like very requires a huge space. So working note we'll have it a small, and we'll work out like this. So we'll just go through the problem. We'll get an idea. TCO is planning to raise funds for an expansion of existing business activities, and in the preparation for this, the company has decided to calculate its WACC. TCO has the following capital structure. So they have equity, reserve, and loan notes. So that is their capital structure. The ordinary shares of TCO has a nominal value of 50 cents per share and are currently trading on a stock market on a ex-dividend basis at 5.85 per share. TCO has an equity beta of 1.15. The loan notes have a nominal value of 100 and are currently trading on the stock market on an ex-interest basis of 103.5. The interest on the loan note is 6% before tax, and they will be redeemed in 6 years' time at a 6% premium to their nominal value. So it is a redeemable bond, and the risk-free rate of return is 4%, and the equity risk premium is 6%. TCO pays a corporation tax of at an annual rate of 25% per year. So that's about the information here. While computing the equity element of book value WACC, we have to have both equity value and the reserve value. So we'll take that number. So that number is directly available. 200 plus 650 is 850. There's no working note. Proportion we'll do later. So loan notes value, book value is 200. So we have to find out the cost of it. So the cost would be, we have to find it and we have to enter. So this we'll leave as of now. So once we have done all this, we'll get the book value of WACC. So we'll now what we'll do, we'll take the same table and we'll paste it again, so that it is easier for us to find out the value. So what we'll do is we'll convert these as market value. So for market value of weight, we don't need reserve, so we'll remove it now itself. We have to find out the equity market value. Equity market value will not be these numbers. We'll remove these numbers, and we'll take the book market value number here and we'll paste it here. Yes, we got the tables now. So our job from here on is just the working notes. So once we have got all the working notes, we can easily put them here. So we'll start from working note 1. So that would be the market value of equity. So to find out the market value of equity, the information is given here. So first we'll find out the number of shares. Number of shares. So number of shares is equal to, we'll take it here, is equal to, if you see, the nominal value of the shares is 200 million divided by the nominal value of each share. Each share is 0.5, so 0.5. This will give you the total number of shares. So the total number of shares is 400 million, Now we have to get the market value of equity. Okay, so market value of equity, you can do it like this: the market price per share. So the market price per share is 5.85. So when you multiply both, you will get the market value of equity. So we'll have that. Okay, so we can quickly get it. Multiply the number of shares into the share price. You got the answer. 2340 is the market value of equity. So you can put it quickly in the value of shares, 2340. So that's done. So next we'll try to find out the market value of loan notes. So the market value of loan notes is like very similar to what we did in the market value of equity. So we can start. Number of loan notes. First we'll calculate that. Then we'll calculate market value per loan note. So we'll arrive at the market value of loan note. Okay, so we'll just start. So if you see, there are 200 million of loan notes, and each loan note is worth 100. So first, there are 200 million of loan notes. Okay, each is worth 100. So divide by 100. There are 2 million loan notes. Okay, each loan note is worth how much? Each loan note is worth 103.5. So you got the answer. The answer is 207. So this is also million. This is also a million, and this is also a million. So either way, we can take this number, the 207, the loan note value, and we can put it in the table here. So this comes to 207. Done. So we'll now move on to the other parts. We need the cost of capital, the cost of capital of equity, and the loan note. So we'll go to the third one. So we'll take it as cost of equity. The cost of equity, we can either find it out through dividends or through the CAPM method. So dividend is not at all given in this problem. So the only way is to find out through the CAPM. So CAPM formula works like this. So that's about the formula. So once we get these numbers, it's quickly we could do it. So we can find out what is RF. So RF equals to, search for RF. RF equals to 4%. So we'll take it as 4. So RF is directly available. Beta we need. So beta, so we need beta. Beta is, so it's given somewhere here. Here equity beta is 1.15. 1.15. Then we need RM. Is RM available? No. Equity risk premium is available. What is equity risk premium? That is RM minus RF. Okay, so that is what is given. That is what is equity risk premium refers to. So RM is not given separately. It is given as RM minus RF, risk equity risk premium. So if you want, we'll mark it here. That is a equity risk premium. So we'll find out the KE. So the KE should equal to, we'll do the formula here. So RF 4 plus, open the bracket, beta comes to how much? Beta comes to 1.15 into RM minus RF. RM minus RF is directly given, so we can take it as into the 6, close the bracket, and we'll get the answer. The answer comes to 10.9. So that should be the KE. So KE is 10.9. Take the number and you can put it on here. Okay, so this number is always a percentage, so don't worry about that. It's in percentage only. and amount is always in terms of the million only. Okay, so all these numbers are like cleanly given. So the same 10.9 is for the book value and for the market value. So we got both the numbers. So now our last step is to find out the, so we'll have to find out the information regarding the loan notes. So we'll have to search it. Loan notes information is in this paragraph, where the loan notes have a nominal value of 100 and are currently trading on a stock market on an X interest basis of 103.5 per loan note. The interest on the loan note is 6% before tax, and they will be redeemed in 6 years time at a premium of 106% to their nominal value. So this seems to be a redeemable bond. Okay, so if it's going to be a redeemable bond kind of a problem, then we have to do a table here. There's no other way. So we'll take it as particulars. Then we'll have, it's a similar like typical IRR problem. So however you work out an IRR problem, the same way we have to work out this. So we have the particulars, we have the cash flow, then we have, sorry, cash flow, then we have the discount factor at some percentage, then we get the PV. So again we have the same two things, we have to do these two things again and we have to get an answer. That's about the table. So the table seems to be like very straightforward. So we'll get the numbers here. So the first number, okay, the particulars that we'll get here is what is the current market value. You have to take the current value, then you have to take interest after tax, and you have to take the redemption value or redeemable value. Okay, so we'll start. Okay, so the cash flow is, the market value of the bond is 103.5. So it's a negative number. The first number is always a negative number, 103.5. So years, in which year this is going to occur? This is going to occur on the 0th year. The next one is interest after tax. So this is, we have to calculate. So we'll calculate here. Interest is 6% before tax and tax is 25%. So we'll calculate here. Interest is 6% and tax is 25%. So 6 into 1.025. So we got the number. So we got 4.5. This 4.5 you can take it here. But this 4.5 will occur for how many years? The interest is for a period of redemption of 6 years. Okay, the bond is redeemed on the 6th year at 6% premium. So 100 is the normal value of the bond. If it's redeemed at 6% premium, it will be 106. So that's how the cash flow. We have to get the discount factor. So whatever the bond after tax interest is, if it's like 4.5, we'll take it as 4, and we'll try to take the same interest. Okay, the 6% interest, and we'll do it. We can take any number as the discount factor, but we'll take the normal interest rate, which is 6%. That itself we will take it as a discount factor. So we take it as 6. This number will always be 1, so you don't need to worry about that. And for this you have to take an annuity factor table. Okay, for this you have to take an annuity factor table, and for this you have to take a discount factor table. So annuity factor table comes to 4.917, and the discount factor for the 6 years at 6% comes to this number. So our job is like very simple. We have to just multiply the cash flow into the discount factor that we found. We got the numbers, and you can still get the numbers. Add all these numbers, you will get the NPV. So as the NPV is negative here for 6%, we have to make it positive or to 0. So what we'll do is we'll take a lower number than 6. We'll take it as 4 and we'll do it. So either way, this summation and things will remain the same. Okay, this multiplication will also remain the same. What only differs is these two discount factors. So we'll find out the annuity factor at 4% for 6 years, and again the discount factor for 6% at 6 years. So we'll try to find out that. We got the discount factors here. We have to then multiply. So when multiplying, be like very careful. You have to multiply the discount factor into the cash flow. The cash flow is here. Multiply those numbers and you will get the answer. So you can just copy the formula and paste it. So you got 3.8. Okay, so you got the number. Now we will find out the KD. So KD is equal to IRR, where IRR is equal to, so the lower discount factor, okay, in this table is 4. Add that number with the NPV at low discount factor, which is this number 3.8. So it's 3.8 divided by again 3.8, because again we have a low discount factor, minus is in the formula. Again there's a minus in the NPV at high discount factor, minus 6.6. Now close the bracket twice. So enter, you will get a answer, and then you have to multiply these numbers. High discount factor is here, this comes to 6 minus 4. So we got the numbers here. Now we'll calculate. You put the brackets here, so that first this gets solved and then we get the answer. So we'll work it out. We'll put an equal symbol in the front, and yes, we got it. And this number would naturally come to 2. So we'll have first we'll have this 4 will be like, again it has to be added. These two elements have to be multiplied. They have to be like multiplied. So we'll multiply this number into this number. We got the answer. So finally we have to add these numbers. So this is your KD. So now we have, as we have got our KD, it's now quite simple. We can take this 4.7 to our table. So this is 4.73. I think that's what we got. Yes. So we can take that number. So we can now, from here on, it's a like very simple multiplications. So this is working note 1. This was working note 2. Sorry, for these we don't have working notes. So working note 1 was for this, and working note 2 was for this, and 3 was for this, and 4 was for this. So we got the working note numbers and we have entered it. So now our job is to get the proportion. So we have to get the sum total, add both these, and you will get the total amount. From there you have to get the proportion. The proportion is this number divided by the total. Okay, total number, rather taking it as formula, we'll take it as the whole number 1050. So you got a proportion. Again do the same, copy it. Okay, you'll get a proportion. So if you want, you can add these numbers. This should come to 1. If it comes to 1, then it's right. So we have our cost. The last step is to multiply the proportion into the cost. So you'll get your proportional cost. Do it for the same, and finally you have to add. So we'll add formulas here. So the answer comes to 9.7. Okay, so this is the answer. So if you want, you will put it here. Okay. So that's about the answer. It just adds. So from here on, it's like very simple here. We can just take this formula, it's a sum formula. So it will quickly sum it, and we'll take this lower. Proportion formula, you can't take it directly because the total proportion changes. So you can work out like this. The equity capital divided by the proportion, which is 2547. Then copy it and paste. You got both. So both of these should come to, so they have come. So now it's just again this formula. Check it once whether the formula is driving properly. Proportion into cost, and proportion into cost, it comes. So now you can take this formula and paste it here. So check whether it's adding correctly. Yes, it adds correctly. So this is the answer. Book value WACC will always be lower than the market value of WACC because market value gives a higher proportion to the equity. Okay, here equity is 91%, but here equity is 80%. That is the reason for the difference between the two values of WACC, because the proportion of equity will always be higher in the market value, and also the cost of equity will be higher number. So that is why this WACC is a higher number. So that is your explanation for the theory question. So that's about this problem. The time consuming element here is the redeemable bond. If you do it in paper, it's much more quicker. Okay, so that's about it. Thank you for watching this video. We'll meet in the next video.